Hey folks, welcome back to the Metal Mill 52 workshop. Appreciate you joining me this week. This episode, about the next half hour I think, is going to be a lot of machining stuff that is involved in the Quorn spindle. I just finished taping several segments that you'll see towards the end of this video that showed all the measurement involved for the distance piece, but I think I've got it right, and as you can see, it looks like it came together well, so I'm pretty happy about that. The next thing to do, I'm going to take it apart, clean everything meticulously, and I do believe I'm going to use, this is the bearing grease that I got from the machine rebuilding company when I bought the bearings, the very expensive bearings for my Bridgeport when I restored it 10 years ago. So I think I'm going to use that instead of using oil, and I also think I'm going to use the little coil springs, because it went together very satisfactorily. So we'll see. I still, even though I'm not complete, I need to clean it and grease the bearings, put it all back together, make sure it's all squared away. And then when that's done, then I need to set it up in the lathe and turn the 40-degree nose taper in there for the WW collets. So that'll be the final thing on the Quorn grinding spindle. But I'm very excited to get to this point. And if you'll please stay tuned for the next several segments, you will see how I did the final machining of the last few pieces and getting everything fit together. And if you're going to build one of these, I would highly recommend this segment for you because it's very interesting. The book has some kind of contradictory information in there about distances, and as I've pointed out, I mean, a simple solution would be make the spindle about a 1/4 inch longer. So, but I didn't do that on the second time around, so I ended up having to make some adjustments, and you'll see all about that here. So stay tuned. Thanks again, everybody. Still thoughts and prayers for the folks in Ukraine. Horrible situation. I hope that resolves peacefully and satisfactorily for everybody involved, and I hope the rest of you are having a good spring. It's where I live. It's warming up out here, you can see, because I'm not all bundled up. So thanks again. Welcome to the new subscribers. I appreciate you and enjoy. Oh, speaking of thumbs up, I never say this, but if you would please give me a thumbs up, make a comment. I do enjoy. I try to answer people if they have questions, and I'm just a hobby machinist, so take my answers for what they're worth. But also, please do subscribe and help pass the word. I am trying to grow the channel. So thank you. I appreciate you, and welcome. Okay, I shot a little segment last night where I measured the length of the protruding threaded portion, and it's like right at 100 thou. And I mentioned that I had made the body about 20 thou too long, but that's really not going to give me very much material, even if I use a piece of steel and make a custom-made nut. So I've been studying on the problem, and one of the things I did, I looked at page 53 of the book, and if you look at this sketch of the spindle, look at this portion right here. The space between the pulley and the body is more like a 1/16 of an inch or so, and also significantly, it looks like the pulley material, that lip of the pulley, if you will, it needs to come out far enough to make contact with the bottom edge of the rear-facing bearing. And also that math goes into the distance, the length of the piece that I just made, that distance piece they call it. So this is going to be interesting. I think my answer is going to be to shorten one of these components so I can reduce this space, bring the pulley closer in, and that will bring the lip of the pulley material through the end cap into where it needs to be to make contact with the inner race of that bearing. So let me show you what I mean. I drew a little sketch of that, but here's the bearing, here's the whole assembly together. Well, it's going to be interesting to do one-handed. But I haven't Loctited any of the fake labyrinth pieces on yet, but I put it together like this because that's essentially how it's going to sit. So let me remove the pulley. Okay, so there's the pulley and the little fake labyrinth piece. As I originally made this fake labyrinth, I call it the rear seal. I made it 3/8 of an inch wide, which is what the book calls for in the drawings. And I say wide, I mean from this point to this point. And there's a lip in there that fits inside the labyrinth seal in the rear of the spindle, that it fits perfectly. So and I've adjusted the length of that where it goes in already, so that's not an issue. But if you take, well, I'm probably not going to be able to do this one-handed, but if you take the end cap off and you put it all together, I'm taking off the last little bit. I'm going to remove 120 thousandths from the back, the thick part, on the rear labyrinth seal piece. So right now I got about 111, a little bit more. That'll give me a little bit of extra distance that the pulley will go in and give me a little extra thread space. I carefully centered it, and I've got the brass pieces there. I'll show you when I get it all done. Okay, there's the modified rear seal with 120 thousandths trimmed off the back of it. As you can see, there's still plenty of space to go seal inside the rear labyrinth seal. And let me put this together and show you what it looks like. This is all part of my plan to let the actual spindle work. So you can see I still have plenty of clearance in between the end cap and the base of the pulley, but it should give me an extra 1/8 of an inch of material for the spindle. Yes, so here we go. Here's the front labyrinth seal in place on the spindle nose. It's not Loctited in place yet. The front of the end cap is not even cranked down tight. Rear end cap is just hand tight. There you see the 1/16 of an inch or so, maybe even more space there. And then that is right at 200 thou of clearance, 188 to 200 thou. I haven't actually measured it yet. I was just excited because that's enough. So now my plan is to make a square nut with a 1/2-20 thread. As you can see, I'll have good engagement with at least 3 threads there for the nut on the back. And making it square will be easy to drive the spindle for the final dimension of cutting that 40-degree taper inside, in the front and the nose for the WW shoreline collets. So yay. I still have to trim 20 thou off the body here, but it's coming together. Alright, I know I said I was going to make the nut out of square stock, but the biggest piece of square stock I had is this piece of 5/8 inch key stock, and that's going to be kind of small for a 1/2 inch nut. Then, looking in my scrap bin, I found this awesome piece of brass, and it's hexagonal, I know, but the ends are not perfectly pointy, so I think they'll grip fine in the forge jaw. There's a little bit of area for purchase. I think I was saving this as leftover from one of my live steam valve projects. I was thinking about making a dreidel or something out of it, but anyway, I think this is going to become my 1/2-20 nut stock. Okay, I really like my choice of the brass nut. Here's one that I made right at 190 thou thick, which is just exactly right for the current situation. Here is one I made that's about 200 thou, 205 thou thick, which I'm hoping is going to be appropriate when I get it completed. So it's a little prettier and a little thicker. That was the one end of the scrap piece that I had. And here's what's left. Since I had that piece and didn't have another use for it, I decided to go ahead and make it a large nut, because who knows, maybe someday I'll make another spindle and this will be some good material for it. Yeah, I thought I'd show how I'm putting the keyway in the pulley. I took a 3/32 cutoff tool, and I cut it and I notched it back so that it will clear the inside diameter of the pulley. And then I've chalked it up in the lathe here and got it set at lathe center height. So now I'm going to use this like a shaper. I've marked the hole, the depth there with the scriber, and all I've got to do is use the lathe like a shaper to shape it out. So let me show you how that works. Okay, just to follow up, I ran the thing through a couple more times and ran a file through there just delicately to remove any swarf, and obviously I'm not going to be using a giant half moon key in the slot, but that's the slot and it looks good. I'm pretty excited about how that came out. You know, I can file it out if I need to a little bit, but looking good. I just need to go buy a little square 3/32 inch key stock from my favorite hardware store tomorrow. Okay folks, just a follow up. Here's the finished product of cutting the slot, the 3/32 inch slot for the key in the pulley using the lathe as a shaper. And I did change the geometry of the cutting tool one more time. I made a huge back relief there. Kind of looks like a little bit like a sword, but it worked out fine. I was able to, making this part narrower, I was able to adjust the cutting angle a little bit sharper, and with this back relief here, it made the cut a lot easier. So you might want to do that if you try this method. Okay folks, one of the things I did after test fitting and to make a change was to very carefully center my spindle outside. I got it within a thou or half thou on the outside, and I got it within less than a half a thou on the inside. So it was centered up and ready to go, and I just used this little boring bar here, and I bored it out. I just made it 20 thou deeper because I noticed that the end cap, these bearing races are 0.275, so 25 thou wider than a 1/4 inch, and the space for the bearing race is a 1/4 inch. So it's a tight squeeze in there. Let me see if I can push this in. And anyway, I just bored it out and I test fit it. There we go. All right, bearing race is in place. Put the end cap, instead of taking any material off the end cap, I thought it would be important to leave the end cap like it was because of the dimensions with the labyrinth seal. But I just took 20 thou deeper cut inside there, and this is good because as you can see I'm tightening it up by hand, so it's compressing against the bearing race, but just by hand I still have at least a fingernail thickness more than that basically, so probably 5 or 6 thou here gap, so that there's still some compressibility is what I'm trying to say. I haven't opened it up so that bearing race is going to be loose in there. So that's just exactly what I was shooting for. Now the other thing I'm going to do is take this out, reverse it, carefully center it again, and just shave 20 thou off the outside of the case because I made the case too long. So I've got the opposite side set up, and I have it, you know, all I'm doing is shortening the half inch, 20 thousandths off this end, but I got to be careful because I don't want to mess up the threads. So I do want to have it centered as well as possible, and as you can see, it's about less than half a thou deflection there. So got that centered, and we'll go ahead and do some work on this one. Okay, well I didn't video it, but after centering this, I just used this little high-speed steel tool to take off 20 thou, and then on the back edge of the body. And my biggest fear was that I was going to goof up the thread, so after I finished shortening this, I used my little deburring tool. It's like a shave-a-viv, I think it's called. You hold it, and it cut the little wire rim off of there on the inside, and it's nice and smooth now. I may even file that a little bit or put some sandpaper on it, but I definitely use a file on the outside to deburr, you know, just kind of smooth that out because you don't want any sharp edges. But happily, this is the rear end cap with a 32 thread per inch. Happily, as you could see, because I was just unscrewing it, it screws in there just fine. So real thrilled that that's not an issue. So now I can take this out, and the rest of the week I'll be doing some additional test fitting, and I'll show you those steps. But so now I've got the front and the back both fitting good, and I have ordered some springs. Found a solution online. I'm going to try both the regular compression springs, and I think I'm going to order some Belleville springs from McMaster Carr, and we can play around with whichever seems to give the best fit. All right, folks, this is what the spindle looks like now after the efforts of shortening the back by 20 thou and deepening the pocket for the front bearing a little bit. Of course, the bearing's not in there right now, but I wanted to just set it up and take a look at the overall fit. And as you can see, the spindle is nice. It's just sticking out just a teeny little bit. This is the 3/16 inch brass hex nut that I made for it. So it's sticking out just a little bit. So right now I'm real happy with the overall configuration. I do need to get the springs, and then I can try with the rear bearing in place and get an idea of where I need to cut the distance piece, the bearing spacer, if you will, that's inside there. And once I have that, then I can finish up, Loctite the little labyrinth seal pieces into place, and we'll go final and get ready to, only remaining machining besides cutting that distance tube should be to put this in the lathe and cut the 40-degree cone for the WW collets, and I'll be doing that just the same way that Matty did in his videos. For this segment I wanted to cover a little comparison. I've never seen this done on video before, but I'm comparing the Belleville disc springs that I got. There's a lot of discussion about these things on the internet, on the Quorn group, about these are a superior springing device to use instead of coil springs. And they're wavy, kind of wavy washer type things, and you put them together back to back like this, so that there's 4 of them in the stack. So I'm going to place them inside the spring box area. I'm going to take the spring box with no coil springs in it, put it spring side down, and then I'll put my bearing and bearing race inside there. Hopefully you can, let me see, pull it out this way. I'll put the race in first, because it's not tight, but it doesn't flop in there either. I guess it's probably the exact right fit that you want. It'll move once it's in there, but it doesn't. You have to place it in just exactly level to make it go in. Okay, there we go. Put the bearing in, inside the race. Now I'm going to put the end cap on. My point in doing this is I wanted to feel what the springiness is like, if you will, and see if it's uniform and how hard it is. So now I'm going to test it. We'll put the pulley in. The little pulley end will press against the inner race of the bearings. Okay, I've done this a couple times now. Check this out. Check out the noise it makes. It makes a clicking noise, kind of like a child's toy, little metal clicker, or like that what they used on the D-Day invasion. So it's interesting. It's kind of either compresses. There's like a couple of different levels, so it's a different feel from the coil springs. Let me take this apart and I'll show you what the coil springs are like. And as I do that, I'll describe. I think I'm going to read up on these, because these disc springs, people rave about them, and I could see that, I mean, they're made for this application. So it may be the choice to make. Take out the bearings carefully, keep them clean. The spring pocket, the disc springs. Okay, let me get my little coil springs out. Let's set these in here. Like I said, I've tested this a couple of times already. You have to kind of press the coil springs in to make sure they're seated all the way down there. There we go. Can you see that? I hope you can. And one more. I've tried this a couple times already. This is my 3rd take of videoing this. I'm trying to be briefer here. So anyway, so there's all the coil springs set in place. I'm going to put them in place facing down in the spring spring area. And I'll set my bearing and race in there. See if I can do that in one take. Yeah, if it's good. And screw the end cap on. There we go. Alright, I'll show you the comparison of the springiness here. I don't know if you can tell the difference. It takes less pressure It seems to have about the same amount, same distance of compressibility, and it seems more uniform using the coil springs, so I'm kind of surprised about that. I'll test it again with the spindle and everything in place, but I may just use the coil springs on this one. I could use the Belleville springs, the disc springs, on something else probably. We'll see. But I just thought you'd enjoy seeing the comparison, because there's a lot of, if you're on the Quorn.io group, there's a lot of discussion about the different springs. So now you get to see them back to back. Thanks everybody. Quick note on the Quorn process. I couldn't find any 3/32 inch key stock, so I had a piece of 3/32 inch brass, thickness wise, but so I marked it and I cut it out, partly on the bandsaw and partly with a hand saw, and I made a very adequate key for myself. I just wanted to show that, since I went into great description about cutting the keyway and the pulley. It came out really good, and I think this will be fine because the pulley itself is made out of aluminum, so a little brass 3/32 inch key. Pointing this out, if I had to do it over again, I didn't realize that 3/32 inch key stock is not universally available. 1/8 inch seems to be, so if you're making this from scratch, in the US anyway, you might want to just go ahead and cut an 1/8 inch keyway. Wouldn't be any big difference there. Probably be easier to do. And certainly easier to find the key stock. So at any rate, that's done. And also, as you can see here, I've got the ends Loctited on the labyrinth seals with the green Loctite, and I've Loctited this one here. So the next step is going to be putting bearings on and test fitting and trying to figure out the exact length to cut the distance piece. And I'm pretty sure I'm going to have to reduce the distance, the front part of the pulley, but that'll be fine. You know, easier to trim metal off than it is to add. So I'll keep you posted as we go along. Hey guys, trying to figure out, the next thing is to cut the distance piece that goes in between the two bearings. So I've got the spindle here, and I've got one set of bearings. I don't have the outer race in place because I don't really need it right now, but distance piece slips over, and I need to cut this a little bit shorter, probably 1/4 inch shorter. I do know what the book length is for it, and that's represented by, I don't know if you can see this here, the calipers, but I don't want to just blindly cut it and then have it be too short. So what I've got in mind, I'm thinking about, I've got it marked actually, the distance there. Put a little scratch mark on it that should be the distance according to the book. So what I got in mind, I'm going to turn the camera off and try this. If it seems to work, I'll bring you back for it. But have in mind about wrapping some tape around here, and then I can slide this through and then put the bearing in place, the back bearing, and put the end cap in, and then press the pulley thing down, because in the last segment you saw me trying it with the different sets of springs and so forth. And we know this needs to compress a little bit, so I'll try pressing it down a little bit, and I can get an idea then for about exactly where that needs to be. And if I ball the tape up just right, I'm thinking when I press it down, the tape will basically stay where it needs to be. And I think there's a little bit of adjustability in here, because the springs, you know, you do have a little bit of pressure, you know, movement that you can use the springs for. So and then when I get all done with all that, then I'll probably have to trim some off the front snout of the pulley. So one thing I did that I haven't showed you yet, I did go ahead and green Loctite the seal on the rear seal on the back of the pulley, and I did it on the front too. So both those things are ready to roll now. So I'm going to turn the camera off, and I'm going to try my tape idea. If it works, I'll bring you back and show you what that looks like. Okay, I thought I'd capture the taking it apart. I just took the nut off and took the pulley out, unscrewing the rear seal now, and let's see. It's a little tricky getting the rear bearing out. It's kind of cool. I mean, it all fits together really nicely. I'm proud of that much. The one thing I had to do a minute ago was I had to put the push the tape down a little bit. When I took it apart the first time, it was uneven, so I wasn't quite sure exactly where the line was. So I kind of crammed it all down to the same spot, and I'm hoping that it's looking very uniform when I take it apart now. But since I put tape in there, the only bad thing is it's a little sticky, so I kind of have to, if you can see what I'm doing here, press it down. There we go. Anyway, so there's the rear bearing assembly, the spring box, and now we can take out the spindle. Well, let's unscrew it here because of the front. Handy to have a little rag because these edges are sharp. Gee whiz. There we go. Better deburr them a little bit before I get finished. Anyway, this is kind of cool to take this apart and see what it looks like. There's the front magneto bearing, and okay, there we go. So that has the desired effect. You could see I mashed down the tape, so it's like a collar position, and it's actually quite a bit shorter than the mark that I had made originally, the factory mark, if you will. So I'm kind of tempted now to do that, to cut the distance piece off at the factory mark and just before, because you can always cut things again if you need to. I think I might do that. I might cut it off at the factory distance. Let's see, which was 2.6875, and here is the, well, no, look at that. Huh. It's definitely within, it's probably just a wee bit shorter than the so-called factory distance. I don't know if you, hopefully that shows up pretty good on there. All right. So I think I'm going to go with the tape. Let me measure that out. This is very interesting. I mean, it seems silly even to try to take a precision measurement on when your source isn't precise, but the factory distance is the decimal equivalent. It's 26875. That's what I've got set on these 12-inch calipers. If I shorten it down to where the tape is, we're looking at 2670. So it's just 15 thou shorter than what the book calls for. So I think we're in good shape there. And as I mentioned, hopefully I mentioned it, I don't know, but I wrote down the pulley snout. I'll have to take at least 105 thou off of the front of that, which is going to be no problem whatsoever, and that should let me screw the nut in all the way. And there we have it. All right, I'm going to turn off the camera now, but let's try some cutting and fitting, and hopefully it all work out. Hey folks, in the last segment I mentioned that I would cut it long first. You know, since the book length was about 15 thou longer than what I was thinking it would need to be. So I did that, and I assembled everything, and I put it together just hand tight, and I could actually hear the distance tube sliding back and forth when I would move this thing like this. So I was like, I'm glad I didn't make it any shorter. So then I tightened this up. I put some wrenches on and tightened the nut up and just backed it off just a wee bit, and actually that took the slack out of it. So I'm pretty happy, and I'm thinking I don't really need to shorten the distance piece at all anymore. Maybe take a teeny bit off the snout of the spindle, but if anything, I mean, we're talking about a very small amount, maybe 20 thou or so, something like that. I may do that, but we'll see. So anyway, I'm thinking this is pretty much the end here, and I'm going to take this apart and look at everything, but I think this will be the last video because I don't want to belabor the point. I've kind of showed the process of fitting things together, and hopefully that's been helpful to you if you're going to make one. But anyway, thanks everybody. This will be the last segment of the weekly update, and I'll do an intro in just a second and publish this thing pretty soon. Thank you.